Okay, 410. More with altitudes and right triangles. I can get it back. There we go. So we're going to graph and write equations for altitudes. Classify right or non-right triangles from a graph. So we've already talked about this before. An altitude is a perpendicular segment from the vertex to the line that contains the opposite side. Key idea has to come from a vertex. Remember when we talked about perpendicular bisectors, they do not have to come from a vertex, but an altitude has to. Now, there are three types of triangles we've talked about: acute, right, and obtuse. When you have an acute triangle, the altitude will come from a vertex and be inside. With a right triangle, it's going to come from a vertex and be on the triangle. It is a side. It's one of the sides of the triangle. And for an obtuse triangle, it's going to come from a vertex, but it's going to be outside the triangle. Major difference. Okay, so graph RST. This looks familiar. 0, 10. Negative 5, 0. And 5, 5. RST. Straight edge. A little bit off. There we go. Okay, now we're going to write an equation using the altitude from T using the following steps. So first, we have to find the slope of RS. Remember, M means slope. So RS. I'm going to go that way, RS. Remember, y on top, 10 minus 0 over 0 minus negative 5. Yum yums on the picnic table. Y minus y, x minus x. So that's going to be 10 over 5, which is 2. And it makes sense that it's positive because it's going uphill. I could write my name on this line and it's going uphill, so it's positive. And we can also verify it. We can go from here and go up 2, right 1, up 2, right 1, and so forth. And all along the way, it's up 2, right 1. Now, what's the perpendicular slope going to be? Opposite, so negative, and flipped, 1/2. Okay? Now, the equation in point-slope form. So for the equation, we need the slope of the new line and the point of the line. Well, if it's coming from T, we need to use 5, 5. So remember, y minus y equals m times x minus x. So we're just going to plop those in. And since t is at 5, 5, that's very easy. Both 5s, and negative 1/2. We now have the equation of the altitude. Okay? Now, we didn't have to do that here, but let's see, where would that be? I'm going to go up 1, left 2, up 1, left 2, up 1, left 2. Here's the point of the altitude. And that does look like a 90-degree angle right there. Once again, we did not have to draw that in, but that's how you would draw it. You would just start from T and move according to this slope. And remember, with the slope of negative 1 over 2, or 1 over negative 2, you can look at it 2 different ways. Down 1, right 2, or up 1, left 2. Same slope. This is the right triangle. Well, let's see. 1, 5, 5, 1, and -3, -3. So A, B, C. Let's draw it. Well, it looks kind of right at B, but how do we know? Well, we need to find the slopes of all three sides and find if there are any opposite reciprocal slopes. So we're going to find the slope of AB, the slope of BC, and the slope of AC. All three sides. So AB, remember, yum yum on the picnic table. So 5 minus 1, I'm going from A to B. I'm just going in alphabetical order. So 5 minus 1 over 1 minus 5. Now look at AB. Should it be positive or negative? Think about that ahead of time. It should be negative. So 5 minus 1 is 4, and 1 minus 5 is -4. So that's a -1 slope. And if you look at it, that makes sense. Down 1, right 1, down 1, right 1. Up 1, left 1, up 1, left 1. That is a -1 slope. Okay, BC. Well, if I write my name on this one, it's going uphill, so I should expect a positive number. Predict these things so you make sure you're doing the math right, not missing a sign. So BC, I'm going to go in alphabetical order, just do BC. On top wise, 1 minus -3, it's going to become plus. And on the bottom, X, 5 minus -3, also going to become plus. 1 plus 3 is 4, and 5 plus 3 is 8. 4 over 8 is 1/2. And then AC, 5 minus -3 over 1 minus -3. Well, that's going to be 8 over 4, which is 2 over 1. So, is it a right triangle or not? It is not. It looks like a right triangle, and it may be like 88 degrees, or 89 degrees, or 90.1, but it's not 90 degrees. How do we know that? Because slopes don't work out. These two are reciprocals, but they're not opposite reciprocals. This one is opposite of the other two, but also not reciprocals. And that's why we can't just look at a picture and assume it's a 90-degree angle. And once again, you can prove that B is not because it's 1/2, right? Well, we go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. That is definitely a 1/2 slope. M equals 1/2. We prove that this is definitely a -1 slope. And again, we could go up 2, right 1, up 2, right 1, and prove that this is a +2 slope. So the reason is no opposite reciprocal slopes. We have reciprocal, and we have opposite, but we don't have both opposite and reciprocal. Is this the right triangle? Let's see. 0, 6. W, 6, 0, V, 0, -6, Q. Well, we already know the slope of that line. There is no slope. So, find the slope of all three sides. WV, slope. VQ, and WQ. Okay, well, once again, WQ, we already know WQ is no slope. And the only opposite reciprocal slope of no slope is 0, a horizontal line. And we do not have a horizontal line. So nothing is right to WQ. Nothing's 90 degrees to WQ. Okay, WV. 6 minus 0 over 0 minus 6. Well, that's going to be 6 over negative 6, which is negative 1. So WV is negative 1, and that makes sense. Again, you could prove it. Down, right, and that looks fine. VQ, this would have to be positive 1 to be correct. So let's do VQ. 0 minus negative 6, which is going to go plus, over 6 minus 0. 0 plus 6 is 6. 6 minus 0 is 6. That's positive 1. Negative 1 over 1 is the flip and opposite of 1 over 1. So this one is a 90-degree angle. Now, it may not look like that because, of rough drawings, but that is a 90-degree angle right there. So, right or not, it's right. 90-degree angle at V. Or you could say WV line segment and QV are perpendicular. Either way is fine. There you go.